it's definitely easy to say, what can we study about a circle? Circles are so simple. And in many ways, the things that you've learned, yes, they are. You certainly know where the center is. And if I call that a D, that would be how you reference the name of a circle. You'd say that is called circle D. You know the circumference. We've studied that. That's pi times diameter. And again, represents that outer edge. And it's the length of that, like circumference is like walking around that outside edge. It's a distance. Radius, of course, you know what it is. It is the distance from the center to the edge of the circle. That is known as a radius. And, of course, all radii are congruent. Part of that is based off of really what a circle is. A circle is all points that are equidistant from a given point, or known as the center point. So we know radius. Now, a new one that you may not know is chord. And a chord is a segment that begins on the circle and ends on the circle. So it is a segment, just as this is, and both of its endpoints must be on the circle itself, is known as a chord. Now, that's interesting because that leads us to a diameter. You also know what a diameter is, but it's defined as a chord that goes through the center. So a diameter is, in fact, a chord because it starts on one end of the circle, its other end of the segment is on the circle, and it passes through the center. And so we know that would be a diameter. Also know that that would be the longest possible chord. You can kind of see that. If you were making chords, they get longer and longer and longer and longer until you would get the maximum length, which is the diameter. And something that's very simple, of course, is a diameter equals 2 radii. Now, these are the things that you would feel very comfortable with, but let me add some new things to you. A tangent line is something that will become important in lots of different places in the future. And basically, a tangent line is defined by a line that strikes the edge of the circle exactly once. So if I had, let's call this line GE, that would be our tangent line, GE. And it strikes it at a location, let's call that M, I guess. This point M right here, this is known as the point of tangency, the location in which the tangent line intersects the circle. A secant line is a line that intersects the circle twice. Again, both of these are lines, not segments, they're lines. And because it intersects twice, we would get, a point here and a point here, and this might be called the segment line AB. I do want you to notice that because it's intersected twice, the circle, there will be a chord that will be formed in there, little AB there. And again, notice, though, that it is a secant line and a tangent line. There are lines. This chord that's formed here is not the secant itself. It's a chord AB inside of that. And we'll study more about these guys. Each of these areas we'll study in much greater depth, but let's talk a little bit about arcs. You know what an arc is. I mean, it's that outer edge of that circle. It's that curved region there. This would be known as an arc. And in other words, it's a piece or a portion of the circle. And there are different ways to name these items. Part of what happens is there's a bit of confusion. If I said, it's arc AB, am I talking about this arc AB? Or am I talking about the green one around the back? So there can be some confusion. So what we do is we have a naming convention to eliminate some of that confusion. So if it is a major arc, now a major arc, what does that mean? It means a value that is greater than 180 degrees. And so again, think of a circle having 360 degrees. You know that half of that is 180. So when your arc is greater than half, you will name it using 3 letters. So for instance, if I had a point, let's say G over here, and I was to name it in the major arc direction, that would be A, G, B. And we would just say that's arc A, G, B. There's no confusion now as to who I'm referring to because it starts at A. Next it gets to G, then B. So it's not going this way. It's definitely going this way. And you'll notice that when we do a major arc, we use 3 letters to name a major arc. The point that you use here can be any point along that traveling, but in this case it was just G on my way there. And this is the way we name an arc. If we're talking about how big it is, we use little m like we do with angles, and we would say the measure of that. And so we might say, oh, that equals, 310 degrees or something like that. So again, the measure of the arc, and this is just naming of the arc itself. If we're talking about a minor arc, that then is when we are smaller than 180 degrees, and we would just name it as expected, the arc AB, or the measurement of arc AB. You'll notice that there is a curve here denoting the arc. You'll notice M when we're talking about the measurement and if we're talking about the object. But because this is less than a full diameter or half of our circle, it is less than 180, and so it's a minor arc. A semicircle, you know that term. A semicircle, of course, represents an arc that is exactly half, right? And so a semicircle is when we are at exactly a half. So we have major, minor, and then we have a semicircle. And in the case of a semicircle, actually, there isn't a direct convention. Like if this is T and H over here, we might call that just TH, arc TH. You might call it TGH. It isn't major, it isn't minor, and so actually I've seen it go either way in terms of that notation. Let's go through this to review. AC, here it is. That's a radius, isn't it? So that would go there. Let's take a look at arc DEF. DEF, the major arc DEF. And that's exactly what it is, isn't it? It's a major arc, so that would be a 2 there. What do we got? This is line CB. Line CB hits the circle once, and that would mean it's a tangent, so that's a tangent line. What do we got next? Point A right here. Well, that's our center point, isn't it? That's easy. Is our center. Arc D, DCE. DCE. Oh, it goes exactly on a diameter. So it's half of a circle. So that's a semicircle, isn't it? All right, let's do point G out here. What is that one? Oh, okay, that's just an external point, isn't it? It's just a point outside of the circle. How about segment DE? Where is DE? Oh, segment DE goes through the center, and so it's a diameter, isn't it? That would be 7 diameter. All right, arc CD. Let's find out what arc CD is here. It's a minor. That's an option. It is. Let's try, what do we got left? Segment CD. Segment CD, that's just a good old-fashioned chord. And then the last one must be DF. So DF is this guy, which is a secant, isn't it? And so it goes there. Just reviewing some of those ideas. Let's put all these items together. Radii, so they give us the radii. And all I'm going to do is put that number 4 anywhere I see a radii in that one. I'm going to put the number 1 wherever I see a radii. Now let's solve a few. BF. BF happens to be a diameter. That's easy. 4 and 4 make 8, don't they? All right, let's check the next one. They're interested in AD. AD is from here to here. That happens to be the radii of the big one and the radii of the little one, which is just a simple number of 5, isn't it? CD, on the other hand, is a little bit more interesting. It is up here, isn't it? And I don't know part of that. But I do recognize that this is a right triangle, isn't it? And so basically it's a right triangle that has what? It has a 4 here, and it has a 5 here. And if I solve this, I hope you know that's a 3, 4, 5. That makes 3 being that whole side of that guy. And so CD is just good old-fashioned 3. And now they want just CG, this portion. So the 3 is the full length, because we use the Pythagorean theorem, minus 1. That just gives us the number 2. And the final thing that they request is the perimeter of that triangle. So 5 and 4 is 9, and 3 is 12. Those would be my measurements. All I would say to you is you'll do ones like this. Just be aware of, really at the heart of this is all of those radii. And in your examples, there may be a little overlapping bit that you'll have to do a little bit of thinking about as to how to calculate it. The last thing I want to do is do a little bit of drawing with you. This says I'm going to draw a secant line AB that intersects circle M at points A and B. So I do know that that's got to be M, right, because of the name here. And I know my line, whatever it is a secant going to strike it twice. And it says it will strike it at 2 points A and B. This is what that particular question would look like. In the next one, we are going to draw a secant line MN and a tangent line TM on circle R. So we know that this is circle R. One thing I do notice is there's an M in both of those, and also that it intersects on circle R. So that means I have a tangent line, and that tangent line is called TM. Now I'm going to put T here and M here. M's the important one because I did notice that M was used in both of those, so that's an intersection point, and it's on circle R. So now I'm going to finish this by drawing in my secant line that goes through M. Right, and what was it called? MN, so let's put an N there. So let's make sure that this is done correctly. Here's my tangent line TM, and MN. M is key here because M is kind of that intersecting point between the secant and the tangent line on the circle R. That looks good. The last one says we're going to create a diameter AB that intersects a tangent line GB on the circle M. So I know my circle is M. Let's draw in our tangent line, GB. And, oh, I noticed B showing up twice, isn't it? So B must be this guy here. And it says that there's a diameter, and it is AB. And this guy was called GB. Let's put G here. Let's double check that we've done everything correctly. I have a tangent line GB, yes. I am on circle M, yes. And my diameter AB intersects at B with that guy. Everything looks good. Good luck with these basics.